This application can scrape any website on the internet using only the URL and the fields that you want to extract. For example, if you want to scrape data out of Hacker News, all we need to do is to get the URL, place it in here, then define the fields that we want to extract. In this case, it's going to be the title, the number of points, the creator, date of posting, and the number of comments, and go back here and define them. So the title, number of points, creator, date of posting, and number of comments. Then we are going to click on scrape. And it's going to start scraping the data. And then it will say, please wait, data has been scraped. And it will basically show me a table in here. As you can see, it's just scraped all the data, give it to me in a table format, in a nice table format. Then I can open it either in JSON, Excel, or I can even open the markdowns if I want. And here, if I open in Excel, I will have a file. And this file will have exactly the data that I wanted. And another thing is that it will show me exactly how much it has spent in order to do this extraction. In this case, for example, the input tokens were 3,868. These are the tokens that we have in the markdowns. Then the output tokens were 1,500. This is what we have inside of the JSON. This table representation as a JSON, and the total cost is $0.0015. It is absolutely cheap because we have used GPT-4o Mini, and here we can introduce as many models as we want. In this case, I have GPT-4o Mini and a GPT-4o. Therefore, if I want more precision and more power, I can always default to GPT-4o, but in this case, GPT-4o Mini does the job for an absolute cheap price. And this works on any website. Let's say, for example, we are going to take another website. This is a website that has listing of cars, and we want to scrape this table that we have here. All we need to do, as always, URL. Here, I am going to define the new fields. So image, vehicle name, vehicle info, condition, sale info, and bids. I am going to click on scrape. It will open the website. It will start scraping the data. And as you can see here, it has basically scraped the data. These are the URLs that will take us to the cars. If I copy one of them and paste it in here, it will take me to the URL of the car, the first car, 8,900, 4,800, 38,000. Let's see, 8,000, 4,800, 3,800. And that is basically it. And that will work on any website. I've tried so many websites, and this application actually works on all of them. Of course, this is going to be a bit more expensive because we have so much more data. Here we have 21,000 tokens. And we are still not even at 1 cent. We are half of a cent. So it makes perfect sense to use these applications to scrape data instead of making more effort to create one script per website. So before jumping into the code and seeing how this application works, and don't worry, we are going to see all of this in detail, I want to actually address the comments that I got on my last video. That was, by the way, about the same topic. I have already created a first version of this application, and there were a lot of comments about, let's say, 3 main categories. So the first one is about how I couldn't get consistent names every time, and how I can use something like Pydantic data validation library in order to make sure that I am going to get the same names. Now, this is something that I had in mind last time, but I didn't want to do it not to make the video very long. But since then, OpenAI have actually introduced structured output, which basically made my life so much easier because now I can define object schemas using Pydantic, meaning that I can basically define the names, and OpenAI with 100% accuracy will give me the same names every time. So that is very important, and it was actually a great remark from you guys. The second thing is about why the use of Firecrawl. Now, there are some people that were genuinely asking about why am I using Firecrawl, and there are other people that just thought I was just, I don't know, sponsored or a tick sale or something like that. First of all, I am not sponsored or anything. It does not make sense for a tiny channel like mine. Therefore, if you can subscribe, it would be amazing. But the idea is, why do we even need to use Firecrawl? We can just read the whole HTML and extract markdowns from that HTML without going through any kind of library. And you're right about that. And I actually did that. This time, we're not going to use Firecrawl. We're not going to use any library. But the use of Firecrawl or Gina AI or Scrape Graph AI, they're actually very good because they simplify the process of us getting the markdowns. We only need 3 or 4 lines of code and we have the markdowns ready. If we don't have that, we will have to go through some ways in order to make sure that the websites that we are scraping are not blocking us from scraping by introducing CAPTCHAs. We have to make sure that the website has to be open on our machine and a lot of other complexities that are not present with all of these other libraries. But still, going through the process of opening the websites ourselves is going to give us so much more possibilities that we didn't have before. So not using file crawl can actually be beneficial, and this is what we are going to do today. The third point is about the fact that this will never replace scraping as we know it today. And honestly, I don't want to argue about this point because I don't know the answer, but what I am sure of is that the established industry of scraping does not have the same innovation pace as the AI industry today. And we can confidently say that because every 2 weeks we have a new state-of-the-art model that outperforms all of the other models and beats all of the benchmarks and introduces a new layer of possibilities. Therefore, dismissing this way of scraping data is not very wise because someone who is willing to get outside of the comfort zone and basically try this new method will at least have a way of scraping data before going into the old way of getting your expat to scrape every element from the website. And there are actually use cases where this would at least give you a starting point. So let's close this bracket and let's continue with the video. Now let's jump to our code and see how I have created this. So the first thing that we start with is some boilerplate imports. So nothing important to see here. After that, we are going to use pandas, beautiful soup, and identic, which is going to be very important. It's what going to allow us to create the schemas. Then we have HTML2 text. This is going to help us create the markdowns. And we have tick token. This is what we are going to use in order to calculate the number of tokens and their cost. And finally, we will have the Selenium imports and OpenAI ones. So the first thing that we are going to start with, and we should absolutely pay attention to, is the setup Selenium. Because if you're just trying to export data using, let's say, for example, requests.getURL without the setup, you will absolutely get the verify you're not a human and solve CAPTCHA. So you have to mimic some human behavior in order for the website not to block you. And this is why I have downloaded the Chrome driver, which you can basically find in here. I will keep the link in the description below. Okay, so the first thing that we're going to start with is create an instance of the options class in order to add arguments to it. First argument is disable GPU. This is important because it's going to help you disable the GPU if you're running this on a VM, and it will basically make it faster because it will not try to initialize any kind of integrated GPU that you have inside of your CPU. After that, we will use this argument. This is to make sure that our Chrome instance that we are going to open is independent and separate, because it will have to access a folder called temp. It's a detail, you don't really need to know about it, but if you are running this code in a Docker container, this will prove to be important. After that, we will define the site. This will help the website think that we are not scrapers, we are actually a human user opening the window. It's really not that important, but it could help. Here we arrive at the first really important argument, which is the user agent argument. And here we have a long text. This is quite important because this is what proves to the website that we are not scrapers, because we basically are using artifacts that are being used normally if we were to open that website ourselves. So everything in here means something. For example, this is Windows 10, this is Chrome and its version, and all of the other things mean something. We don't need to go into details, but these are just artifacts that usually are present when we are opening a website ourselves. After that, we will open the service that I already have inside of my project in here. And then we are going to initialize the web driver and we are going to return it. We then get to fetch HTML as Selenium. And this is where we are going to open the URL. And then we are going to add some sleeps and mimic a scroll action, which always going to help us not to get blocks. And also, this is quite good. If we have an infinite scroll case, this is how we can do it. We can just add 3 or 4 in here, just so that all of the data is being loaded. And then we can get the page source and then return the HTML. And then we have driver.quick inside of a finally, just to make sure that if something crashes in here, we still are going to close our Chrome instance and not leave it open. This is quite important. We then get to the part where we are going to create markdowns. Here inside the clean HTML, we want to keep only the main content. So what we are going to do is that we are going to remove the footer and the header using decompose. Unless you want to scrape some information from the header on the footer, you should probably comment this part. After that, in HTML to markdown with readability, the goal basically is to get the HTML content that we are going to retrieve from clean HTML and get it into a format that is readable. much like the markdowns that we had with Firecrawl. So it's actually the same. I've compared between the two and it's actually the same. So here we are going to initialize markdown converter with HTML to text, and then we are going to define ignore links as false. I've actually tried this with true, but still it did not ignore the links. It kept them inside of the markdowns. And then we are going to use the handle function, and this is basically the function that it is going to take our HTML text and create markdowns that are kind of readable by human beings. It's not 100% readable. It's not like structured data or anything, but they are like semi-readable data for us. And of course, these semi-readable data is actually very good for large language models because it helps them tremendously to get structured data. After that, we are going to define our models. Here I have GPT-4o mini and GPT-4o latest version, and all of the pricing. We are going to use that in the function calculate price. But for now, we just define them, and then we define the model that is going to be used, which is our GPT-4o mini. After that, it's basically the same code as I have created last time. I have save raw data, which means that we are going to take these markdowns and then we are going to save it. After that, I have added a function to remove the URLs. This is basically just to offset the ignore links that I had before because it did not work. And we get to the most important part, which is creating the dynamic schema that we want. And as you can see here, it's not a very complicated function, but at the same time, it is very, very important. So here we define our return type, which is going to be type base model. And if you read the comments, you're going to see that I'm going to dynamically create a pydantic model based on the provided fields. Before actually adopting a list of strings, I was using a dictionary because I have said maybe sometimes if the user basically defines some kind of, let's say, fields that are not well written, I will read the data and then I will reconstruct these names that I have in the fields so that the model can do a better job extracting them. But then this means that I have to add another part where I am going to call ChatGPT, meaning that it's going to be more expensive. So this is why I just decided to go with a list instead of dictionary. So this dictionary that was gonna basically have field aliases of external names and internal names is very good, but at the same time, it is going to be more expensive. This is why field name should be a list of the fields that we are going to extract from the markdown. So here we have a little syntax in order to create the schema that we want. And if you're not really familiar with this, all I'm doing here basically is just trying to create these formats dynamically. So instead of just defining one of them, I'm just going to read whatever the user is going to give me, and I'm going to try to create this. I'm going to create them in this specific format. Let's say, for example, I have this. And then it's going to be a tuple inside of here with 3 points, for example, if the fields are explanation and output, just so that this will be a mandatory field, which is going to prevent ChatGPT from giving me empty fields. Because I've tried it with empty fields, just with SCR, and sometimes I get a lot of empty fields where I shouldn't. This seems to help it give me a more reliable output. So let's delete this. And here we basically have a return of the dynamic listing with the field definition that we have just given. And now we have a model. We need to put it inside of a container because we don't want just one listing. We want multiple rows, and our input is going to be type-based model, which is what we have here. And our output is going to be a list of these listing models that we just got in the input. So this is going to be our dynamic listing container, which is going to contain all of our data. After this part, the only interesting thing that we need to do is to basically count how many tokens we have used and then the price that we have paid for the extraction. But before that, we need to trim our token limits. Sometimes if a website is crazy enough to have more than 200,000 tokens. I think even Amazon only have, like, worst case scenario is going to have 40 or 60,000 tokens per page. If a website has more than 200,000, we need to trim it and only take the first part, which likely going to have the data. And then we are going to basically call GPT-4o or Gemini if we decide to do so. So this is the function format data that is basically going to take the data and the dynamic listing. And then I already have my prompt in here. By the way, I didn't change it from last time. It seemed like it was working all the time, so I didn't really need to change it. And here we have client.beta.chat completion. So maybe this will change in the future. And if this project proves to be important to you guys, I will just come back to this code and basically update this part. But the most important thing is the structured output, which basically means that I only need to add this one line of code and I will be guaranteed 100% of having the same names every time, meaning no post-processing of my outputs, which is absolutely amazing. Then I will get the data parsed, and from there, I will use the same functions as I've used last time. Now we reach the save formatted data, and here what we are going to do is basically try to save our data as JSON and then in a table in an Excel sheet. So we are going to take the formatted data, and then we are going to check if it has a dict, which is going to be the case since this is an instance of the dynamic listen container pydantic schema. So it should have a dict. So we are going to basically take that dictionary and we are going to put it inside of a new variable called formatted data dict. And then we are going to save that variable as a JSON format using the json.dump. And after that, we are going to check if that formatted data dict have either one value or have multiple values. If it only have one value, that means that we have one key, which is going to be the case. We have listings, and inside of them we have all the data. So it has that one value of listing, meaning that inside of it we are going to have all of the data that we want. So we are going to take the values from inside of that one listing value. We are going to be able to see it here. Here we have listings. We're going to check that we have only one value listing, and then we are going to take all the values that we have inside of that listing. And from there, we are going to put it inside of a data for data frame, which we are going to take inside of a data frame, which we are going to create an Excel file with later on in here. And the last function that we have, which is going to be the calculate price. And basically this calculate is going to use an encoder to take the number of inputs and then another encoder to take the number of outputs. And then we are going to calculate the price depending on the pricing model and then input output in the dictionary that we have defined before. And then we are going to return all the values. Here I was testing this model in here. So you can use another file where I have examples that you can basically just copy paste in here in order for you to test only this part. But the workflow itself is going to be called inside of the Streamlit application. So inside of our Streamlit application, of course, we are going to have Streamlit, and then we are going to use the tags. This is quite important because only this way we can basically have this format for the tags, names, etc. So this is the library that is going to help us to do so. We make sure that we are taking it for the sidebar, and then we are going to import all the functions that we already have defined in Scraper. So we're going to start by some boilerplate to define the title, and then we are going to define what we are going to have in the sidebar. So here we have the select box. I am a bit lazy. I should probably take these values from inside of here. I should have the same values that we have inside of the models that we have inside of pricing. Then we are going to have the tags, and these are basically the configuration of the tags. Just make sure that you have max tags as -1. If you want to add some suggestions, if you basically want to make a better user experience, and if you already have a prior knowledge to what people are going to scrape, you can either add them at the value, so they are already there when you open the application, or you can add them as a suggestion. I left it empty, but you can change that if you want. And then we will have a markdown just to separate the two parts. And here, because I was using a dictionary before, that's why I have fields equals tags. I had a little function in here, but it does not exist anymore, so do not pay attention to this. And then this is basically my workflow. As you can see here, perform scrape, and it's going to go through all the functions that I had before and going to return all these values. And all of these values are going to be used in here. So if perform scrape not in session, if this is the first time I open it, I am going to set it to false. And then only when I click on scrape, this is where I will have my spinner. And then I will call the perform scrape and put the results inside of here. Once this is finished, it's gonna go here, and then it will put all of the values inside of these variables from the results that we have in the session state, and then it will start displaying them. Here I have created some kind of columns because the buttons were all over the place. And as you can see here, this is actually download, not just open. As you can see here, we have the download JSON. And in my column 2, I have data dict, where I am going to get the formatted data for my pydantic schema, as we have talked before. And then I will get the first key, and I will access that first key using the data dict. And then I will transform that into a data frame. And then I will basically use that data frame. I don't understand. What did I add this in here? This does not do anything. Okay, so I don't understand. This does not do anything for me. I don't know why I added it. Anyways, so here, as you can see, I will basically use that data frame and I will transform it into a CSV, and then I can just basically download CSV. And After I did that, actually, I discovered that if, for example, I want to scrape, let's say, a scrape.me website, let me take it really quickly. Let me put it inside of here. Let me click on scrape. So I discovered that when I get a table in here, I can actually download the CSV. So all of that work that I had to do on the data frame did not mean anything, because basically I can just download it in here directly, and we are going to see that now. So as you can see here, I will have download. So I can just download a CSV. So this is basically just name and price, and I am scraping data out of this website, which is a website scrapers normally use just to try their scripts. So that's very good. Last thing we need to talk about is this 2 lines of code, which are very important. So whenever I am changing something inside of here, let's say I am going to change this to GPT-4 Mini, it's very important for the user experience to have all of this to stay the same until we click on scrape. So these 2 lines just basically make sure that the session state will always keep these values so that we show them. And unless we click on scrape, this will not change. And that's it. If you guys have any comments, if you guys think I've forgotten something, or if you have suggestions to basically enhance this script, I'm all ears. Just drop them in the comments. Thank you guys so much for watching. Don't forget to like and subscribe, and I will catch you guys next time.